Hello students, welcome to Learner's Planet, Theory Session 2 of Periodic Classification of Elements. In our previous session, we discussed about the attempts made by Dobereiner and Newland to classify elements. In this session, we will be discussing about the Mendeleev's periodic law and his periodic table. So let's start our discussion. Now this Mendeleev's periodic table, he was the first person to tabularize the elements, to arrange the elements in the tabular form. Now this Mendeleev's periodic table, there were 63 elements known when Mendeleev started his work. So he was a Russian chemist. When he started his work, that is assembling of the elements and arranging them, there were only 63 elements. It's not like today, we have got 118 elements today. Now what he did, he arranged elements on the basis of chemical properties and atomic weight. Now what he did, among chemical properties, he concentrated on the compounds formed by elements with oxygen and hydrogen. Why? As hydrogen and oxygen are very reactive. So what he concentrated on? He concentrated on the compounds formed by elements with oxygen and hydrogen. If we talk of chemical properties, students, there are lots of chemical properties like the reaction with halogens, like their hydroxides, like their valencies, like their carbonates, like their bicarbonates. But what he did was, he concentrated only on the two properties, that is the reaction with oxygen and hydrogen. Why? Because these are very reactive. Now what he did was, the formula of hydroxides and oxides formed by an element were treated as one of the basic properties of an element. So what he did was that the formula of the hydroxides and oxides were treated as the basic property of the element. Okay. Now let's see what's there in the Mendeleev's periodic table. What he did, elements were arranged in the periods and groups. The Mendeleev's periodic table consists of 12 horizontal rows named as series. The periodic table which he gave originally, that consists of 12 horizontal rows and he named them as series. These series are further divided into horizontal columns called periods and 9 vertical columns called groups. So what he did, that these series are further divided in the Mendeleev's original periodic table. If you see, what you'll find is that there are 12 horizontal rows and these are further divided into horizontal columns and these were called periods, and there were 9 vertical columns and these are known as groups. The elements with similar nature, that is the nature of their oxides or their hydroxides, are placed in the same group with respect to the atomic number. Okay? And at some places, so what is happening here, that he took two things in consideration, the chemical nature, that is their nature of hydroxides or oxides, and he placed them in the same group with respect to the atomic weight. So he had to see two things, the chemical property as well as the atomic weight. Now at some places the order of atomic weight was changed. Why? In order to justify the chemical nature. So he had to change the order. What he did was that his periodic law states that the chemical and physical properties of the elements are the periodic functions of their atomic weights. Now, in order to justify the chemical nature, what he did was he changed the order of the atomic weight. The periodic table given by Mendeleev had anomalies, so several modifications were made. So students, this was the original periodic table given by Mendeleev. Then as he changed the order of atomic weight in order to justify chemical nature, his periodic table was not suited. There were lots of anomalies, like similar elements were placed in different groups, different elements were placed in the same group, and so on and so forth. So, certain modifications were done. And students, do you know that in this Mendeleev's original periodic table, there was no place for transition elements, or there was no place for lanthanoids and actinoids, as well as for the zero group elements, as they were not discovered at that time. They were discovered later. So, several modifications were done. Now, let's see the Mendeleev's modern periodic table. What are the things in that? So, the periodic table which you find in your books is the Mendeleev's modern periodic table. And in this, elements are arranged in 10 horizontal rows known as series. How? In the increasing order of their atomic weights. Because, this Mendeleev took atomic weight as the basis for classification. He didn't take atomic numbers. Now, in this, what is there? There are 10 series were grouped into 7 periods and 9 groups, that is 0 to 8. So students, this is very important. You have to remember the number of periods and groups in Mendeleev's periodic table or the modern periodic table. If the question is asked that how many periods and groups are present in Mendeleev's periodic table, what you have to write is 7 and 9, not that of the original one. Now leaving 0 and 8th group, each subgroup is subdivided into 2 subgroups A and B. So these are the features. Now this is the Mendeleev's modern periodic table. I'll just try to show you this, which is okay. I hope this is visible to you students. So here it's the Mendeleev's periodic table, that is hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Now you can see here, you don't need to remember the names of the elements present here. I just wanted to show it that how this appeared, how it appeared in this. Can I just zoom it more so that it's clear to you? So students, what it is that what you have to remember is how many groups are there. Just check out 1, 2, 3, 4, 5, 6, 7, 8 and the 0 group. So these vertical columns are called as what, students? These are called as groups. And the horizontal ones are called as what? The periods or the series. Got my point? So these are what, children? These are what, students? 1, 2, 3. These are all the groups. And periods are the horizontal ones, like hydrogen. This is again hydrogen and helium. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So likewise, these are the periods. Now here you can find out, students, like the period number 4. So what all are the things here? What he did was that he grouped into A and B. This is A, potassium, calcium, scandium, titanium, vanadium, chromium, manganese. So this is A. And its B is what? Copper, zinc, gallium, germanium, arsenic, selenium and bromine. So this is B. So what he did was that he divided the series further into A and B. Now in this students, you can find out that every group is subdivided into A and B, every group, excluding the 8th and the 0 group. Now these are very small key points, students. You need to remember this. It's not that once the Mendeleev's periodic table has been, or Mendeleev's periodic law has been discarded, you are not going to remember this. This is very important because as it was the first attempt to classify elements. So these are the basic things which you need to remember. Mendeleev's periodic table has 9 groups. Except for 8th and 0 group, all are divided into A, B, A, B, A, B and A, B. Okay? And the series, how many periods are there? 10 series are there, and he subdivided it further. Okay? Now in this you can find out the arrangement is according to their atomic weights. Like your sodium is 22.91, magnesium is 24.32, aluminium 26.98, silicon 28.09, phosphorus 30.97. So these are according to the atomic weights, and the atomic numbers are given. But what happened? That there were certain elements where anomaly again came. What was it? That the element with the higher atomic weight came first and the element with the lower atomic weight came later. Like your cobalt, it is 58.94, whereas nickel is 58.96. So this is a very shorter type of anomaly, or in this the arrangement was disturbed. And students, what he did was he made the 0 group for for noble gas elements. This is what modern Mendeleev's periodic table. This was not the original one. In the original one, what was happening, that there was no space for the 0 group elements, and of course the lanthanides and the actinides. Now in this, see what he has done. He has done this lanthanoid series starting from cerium till lutetium, and actinoid series starting from thorium till lawrencium. So this was the modern periodic table given by Mendeleev. Now students, after doing so many changes in the periodic table, still there were certain anomalies or the drawbacks. So we will move to that. Let's see what are the anomalies and the drawbacks. I'll have to do it. Okay. Now this brief of Mendeleev's periodic table. First 7 groups were of normal elements and the 8th group was of transition element. Noble gases were not known at that time, so there was no group of noble gases in the Mendeleev's original periodic table. They were placed in 0 group in Mendeleev's modern periodic table, as I told you. Okay, so if I move to this thing again, so this is the first 8 elements till here. These are what? These are the normal elements, and these are what? They are the transition elements. Okay, so they were placed in the 0 group. Who? The noble gases were placed in the 0 group in Mendeleev's modern periodic table. There was no place for lanthanides and actinides in Mendeleev's original periodic table, but they were placed below the periodic table in Mendeleev's modern periodic table. Okay? The elements in each group of periodic table have similar properties. That is, the elements in each group, in every group, the elements have got the similar properties. Now this was Mendeleev's periodic table. Now let's check out for the merits and the demerits of Mendeleev's classification of elements. Now first we will check out for the merits of Mendeleev's classification of elements. What was it? Mendeleev made the first attempt to arrange the elements in tabular form. Okay, so what Mendeleev did was, he was the first person to arrange elements in tabular form. The comparative studies of elements became easier. So obviously students, what he did was, he arranged them in a tabular form. So you can compare the properties of two elements. Okay. What else were the merits? Discovery of new elements. At the time of Mendeleev, about 63 elements were known. And what he did was, and thus he left vacant places for the unknown elements, which helped in their discoveries later. For example, gallium and germanium were discovered later, but Mendeleev predicted their existence and properties, referring them as Eka aluminium and Eka silicon. So in his periodic table, what he did was that after silicon, he left a vacant space and named it as Eka silicon. And after aluminium, he named another element, that is Eka aluminium. Now these elements had the properties similar to the other elements in the group. So later, after the discovery of these elements, it was found that the properties of Eka aluminium and gallium, which was discovered later, had similar properties or were similar. Okay, so these were what? These were similar. Now let's see how these were similar, or what are the properties which are similar. Like property, atomic mass. Eka aluminium means, Eka means after, one. That is, after aluminium there is one element. Eka is a Sanskrit word. Now this is 68 and gallium was found to be 69.7. So it was approximately similar. Now formula of the oxide formed by Eka aluminium was E2O3 and that of gallium was Ga2O3. Formula of chloride of Eka aluminium was ECl3 and that of gallium came out to be GaCl3. Likewise, the element which he named Eka silicon, that is the element after silicon, it was germanium. Later it was discovered and it was named as germanium. So the properties of Eka silicon and germanium were the same. Let's see few more merits. Mendeleev's periodic table could predict the properties of several elements on the basis of their positions in the periodic table. What he did that he arranged the elements on the basis of their chemical properties as well as their atomic weights. So he could predict the property of an element, or if we are seeing Mendeleev's periodic table, we can predict the property of element by seeing the group, by predicting by its position. Valency of many elements were corrected, that is, beryllium for example. Beryllium was assumed to be trivalent. What do you mean by trivalent? An element or an atom with a valency 3 is trivalent, but it was later reported to be bivalent. So these are few merits of Mendeleev's periodic table. Now there were certain limitations also. Limitations mean certain drawbacks also. The limitations of Mendeleev's periodic table, what were they? Some elements with similar properties were placed in different groups, whereas elements with different properties were placed in the same group. For example, tellurium, its atomic weight is 127.6. It was placed with molybdenum with atomic weight 95.94, and this was placed in group 6 They had different properties. Now what are these? Say your tellurium. Tellurium belongs to group 6, that is, it belongs to the oxygen family, or the chalcogens, the oxygen family, that is oxygen, selenium, oxygen, sulfur, selenium, tellurium and rhenium. This has got 4 electrons or 6, this has got 6 electrons in its valence shell. That too, the valence shell has got p orbital. But molybdenum is a transition element. It has the properties in between the metals and the non-metals. The last electron in molybdenum is in d orbital. So, tellurium is a p block element, as the final electron or the last electron enters p orbital. We will be discussing about these orbitals later, but you just remember this. And molybdenum, the last electron enters the d orbital, and they have got lots of differences in their properties. Likewise, vanadium. Vanadium is also a transition element, so, or the d block element, whereas arsenic, it is a non-metal, where it is nitrogen, phosphorus. In the 5th group, it is. So, nitrogen, phosphorus, arsenic, antimony and bismuth. So, these are the elements of the 5th group. So, these two again had different properties. So, these were placed in group 5 and had what? Different properties. Now, let's see a few more limitations of this. Some elements with higher atomic weight were placed before lower atomic weight elements, like cobalt, it is 5927, nickel 58.7, and 28 is the atomic number. But there were elements which were arranged according to their atomic weights, like ruthenium 101.7, rhenium 103.0, palladium 106.5. So it's not that all the elements are arranged, they have anomalous arrangement. There were elements which were arranged properly as per their increasing atomic weights. But there were certain elements like cobalt and nickel, in which element with a lower atomic weight or higher atomic weight comes first and a lower atomic weight comes afterwards. Okay, so these are the elements which are arranged correctly, whereas these are arranged in a wrong manner. Now in this case, students, isotopes were not given any position in the periodic table. Now could you tell me what are isotopes? Isotopes are the types of, or these are the elements with isotopes. These have what? These have same atomic number but different atomic masses. Just like here, just see this. Hydrogen, it has what? It has its 2 isotopes, deuterium and tritium. Deuterium has got the atomic weight 2 and tritium has got the atomic weight 3. If I write hydrogen, so what it would be? Hydrogen has the atomic weight 1, atomic number 1. Deuterium I have already written there, atomic weight 2, atomic number 1. And tritium had the atomic weight 3 and atomic number 1. So, there was no place for the isotopes. Like for example, chlorine. Chlorine has got 2 isotopes. 35.5, the atomic weight of one is Cl35.5 and the other is Cl37.5. So there are 2 isotopes of chlorine also. Likewise, students, there are many elements which have got isotopes. So he couldn't assign any position to the isotope. If he is arranging elements on the basis of atomic weight, he should have kept position for or the places for the isotopes also. But he didn't do. Well, let's take up few more anomalies, like position of hydrogen could not be made clear. He had, if you remember the periodic table when I was discussing, he gave two positions to the hydrogen atom. One is the first and the other one was 7. So he gave two places to hydrogen. The electronic configuration of hydrogen resembles that of alkali metals. Like alkali metals, hydrogen combines halogens, oxygen and sulfur to form compounds having similar formula. I'll elaborate this. Like hydrogen. So what is the electronic configuration of hydrogen? It is 1s1. And the electronic configuration of sodium here is 2s1. The electronic configuration of potassium is 3s1. That is, these are having only one electron in the valence shell. So they form similar types of compounds, like with oxygen, say, hydrogen forms H2O. Sodium forms Na2O. Potassium forms K2O. Likewise, hydrogen forms HCl. Sodium forms NaCl. Potassium forms KCl. So it is forming the compounds with a similar molecular formula. Now let's see the other point, that is, just like halogens, hydrogen exists as diatomic molecule. Hydrogen, how it exists? It exists as H2. Halogen, how they exist? Cl2, Br2, I2. So it is just like halogen also. And it combines with metals and non-metals to form covalent compounds. So hydrogen is not forming ionic compounds like alkali metals. So these are the properties of the hydrogen. So the position of hydrogen could not be made clear, whether it is to be kept in the first group or in the 7th group. Now let's take up few more anomalies of this. Okay, this is the repeated one. Some elements with higher atomic weight were placed before the lower atomic weight elements like cobalt and the nickel. It could not explain the variable valencies of elements. Variable valencies means, say let's take iron. Iron has got valencies 2, 3. Manganese, it has got valency. It has also got 1, 2, 3, 4, 5, 6, 7. So there are elements with more than one valency. So he couldn't explain that. Why? Because valency depends on the number of electrons in the outermost shell or the combining capacity of the elements. But what he did, he arranged the elements on the basis of their atomic weights. So he couldn't explain the variable valencies of the elements. Now the atomic masses do not increase in a regular manner in going from one element to the next. So when you'll see the Mendeleev's periodic table, you'll find out that the increase in the atomic weight is not regular or they are not consecutive, as there were very few elements at that time and the increase is also not consecutive. So it was not possible to predict the number of elements that could be discovered between the two elements. So it was not possible to predict the number of elements that could be discovered. So students, these are all the merits and the demerits of Mendeleev's periodic table. And you have to remember the features of table, the merits as well as the demerits. So we will be meeting in the next session and I'll tell you about the modern or the long form of the periodic table, the Moseley's periodic table or the Bohr's periodic law. So till then, just go through this periodic table. So thank you very much, students, for listening patiently.